Sometimes proving these parallel line theorems does take a few steps. This is an 8-step proof, 2 columns, and we've got a given that P is parallel to Q, so this first reason we'll go with given. And let's take a look at what we're trying to prove. We're trying to prove alternate interior angles are congruent, and so we want to prove 3 and 5 are the same. And in order for me to talk about 3 and 5, I really need to probably talk about the fact that 4 and 5 are same side interior angles. Those add up to 180. So do 3 and 6. And if 3 and 6 add up to 180, and 5 and 6 add up to 180, maybe you can see a relationship between 3 and 5. These are same side interior angles, and this right here make a linear pair or a straight angle. This is 180, 5 and 6, 3 and 6 also 180, and if I take away the 6, I'm going to get 3 is equal to 5. Let's go take a look at the steps. Angle 3 and angle 6 are supplementary. That is the same side interior angles postulate. That's about as much as I'm going to abbreviate it. 3 and 6 add up to 180. Well, if they're supplementary, that's the definition of a supplementary angle, because supplementary angles add up to 180. Angle 5 and 6 are a linear pair. Well, when you say something R or something R, usually it's a definition. This one's a postulate. If I say something is a linear pair, that's the definition of a linear pair, which just means 2 angles that are made up on a line. And angle 5 and 6 are supplementary. Well, that's also the definition of a linear pair. You could probably make the argument that this step could have linear pair theorem, and I don't know if this could be called linear pair theorem, but sometimes you come up with different rationale, and it's okay. 5 and 6 are 180. Well, that's the definition. If I just said they're supplementary, they're 180. That's the definition of a supplementary angle, and you can see where this is going to go. The next thing we're going to do is say, well, I've already got this equaling 180 and this equaling 180, therefore 3 and 6 must equal 5 and 6, and that's substitution. And in order to get 3 and 5 be the same, I got to take 6's and subtract them out. So if I subtract those, that is the subtraction property of equality. And that's about enough of an abbreviation on that one. And now we can say that angle 3 and angle 5 are always going to be congruent. They are alternate interior angles. Now we've proven it, so we don't have to ever prove it again. We're going to try and prove now the corresponding angles theorem. We already know alternate interior angles are congruent. We could use that in a reason. We could also use the same side interior angles postulate, that same side interior angles add up to 180. Let's go through our steps. The first thing we've got is that line P is parallel to line Q. That's given. And now I'm trying to draw a connection between 1 and 5, and I want you to see the connection between 5 and 3. Those are alternate interior angles, and the last proof, we just prove those things are congruent. So the second step is now got to say angle 3 is congruent to angle 5. And that is the alternate, and we're just going to write alternate interior angles are congruent. That's going to be our reason. We're not going to call it the alternate interior angles theorem. Let's just make a statement. And if angle 3 is congruent to angle 5, I've got to introduce angle 1 into this proof. 1 and 3, I wonder if you remember what kind of angles angle 1 and 3 are. They are congruent because they are vertical to each other. So the reason for this next step, vertical angles are congruent. And the last reason, if 3 is equal to 5 and 1 is equal to 3, I can now say that angle 1 is equal to angle 5. And I guess I should probably say angle 1 is congruent to angle 5. And that is by substitution or the transitive property. Either of those is okay. And once you say that 2 angles are congruent, then we could have one last step that says the measure of angle 1 is equal to the measure of angle 5, which is what we were asked to do. And the reason of this might seem a little bit mundane, the definition of congruence. Whenever you say something is the same, their measures are equal. And I know, I'm sure it sounds real genius, but that's the reason for that last step. So let's wrap up this video with this problem. It says that roads A and B are parallel. That means this line A is parallel to road B, and I just highlight them in pink, and you can see this becomes my transversal. So now the parallel lines are turned a little bit on their edge, and A is parallel to B, and they want us to find angle VTU. And so if I look at V is here, there's VTU. And what they're asking me now is, how many degrees is this thing right here, 2x minus 22? And you can look over here and you see this one over here is x plus 40. And so really the trick is, can you identify what the relationship is between these two angles? They're on the outside of the parallel line, so they're exterior, and they're on different sides of the transversal. This one's on the top, this one's on the bottom. So these are alternate exterior angles. And alternate exterior angles are congruent. So these two angles that we're looking at are equal. X plus 40 is equal to 2x minus 22, and we can solve that for x. I'm just going to take away an x, and at the same time I'll go ahead and add a 22 to both sides, and I'll get x equals 62. And that's not what the answer is. The problem needs me to go find an angle for VTU. Well, if x is 62, this is 2 times 62 minus 22. So that's 124 degrees. Take away 22. So the measure of angle VTU is 102 degrees. So looking at this second problem, we see line A is parallel to line B, and I see two angles that I am given. This one here is 9x. I can describe it as a little acute angle, and one thing I know is this angle will be the same as every other little acute angle in this drawing. And this is 2x plus 25. This is the obtuse angle. It will be congruent to every, I'm going to try and draw two arcs there. It'll be congruent to every other obtuse angle in this drawing. And see, I can look at 9x, that's the acute angle, and this big one is the obtuse angle. This angle and this big obtuse angle are supplementary. And this angle that's called 9x is also supplementary to this angle right here, which is called 22x plus 25. So these two angles aren't equal at all. They are supplementary. 9x plus 22x plus 25 equals 180. And now it's time to combine our terms at the same time. I'll take away 25 on both sides, and I'm going to get 31x equals 155. And when I divide this by 31, I'm going to get x equals 5. And now the question was asking me to find the measure of angle WUV. That's this one over here. That's this 22x plus 25, which is now 22x plus 25. And 22 times 5 is 110 plus 25. That is 135 degrees. So the measure of angle WUV is 135 degrees.